So when you did input and output in C, you would have done things like printf, fprintf, and you would have ended up dealing with files. Okay? Files and streams in C++ work a little bit different. You have these I/O streams, input-output streams. You can have an I stream, which is just an input stream. You can have an O stream, which is an output stream. You can have an F stream, which is a file stream. And as we saw in week 1 with like Hello World, we had for input and output redirection. Okay? So you have some data and you redirect it into a stream. There's a whole category and a whole flowchart there of how these different input-output streams work. We're not going to cover this in a lot of detail, but be aware that there's a lot of different types of streams and they're used for a lot of different purposes. The ones that we'll be focusing on is the input-output streams and the file streams. Okay. And so there's 3 of them that are already predefined. There's CIN, which is the standard input, often for keyboard. Okay. There's COUT, which is the standard output, which you would have seen last week, whereabouts we're printing to the terminal window. And there's CER, which is the standard error. Okay? So you've got 2 streams for output. You've got standard output and you've got standard error. And so you can print your error messages to a different output stream. You can redirect these off a different output stream. And so you can use that for when you're building things to not display error messages that maybe are technical programming error messages to the end user. You might want to redirect that out to a log file. Okay? And so there's a very small program sitting down there, or a very small code snippet, where you have an int I, a float f, a string s, and a complex number c. And for all 4 of those different types, okay, you can read them from the keyboard. So using cin, you can read them from the keyboard. Using cout, you can print them to the screen. And using standard error, you can print them out to wherever the standard error is being redirected to. Note also for redirection operators, for less and less than and greater than greater than, okay? For input and output, they change directions. Very easy mistake to make if you get those arrows the wrong way around, okay? So to do files, here's a very small set of code that allows you to input and output on files, okay? We hash include IO stream. We hash include F stream for file stream. Again, okay, this isn't a complete program, but you could easily convert this into a complete program. You have an I. You have the file F stream here. Okay, so input file stream. You then open the file that you want to write to. Okay, this is very similar to C. You have to open a file, even if it doesn't exist. You have to open it for writing. And then sorry, this is for reading. Then, while there's data in that file, read that data into I and print it out. And then close the file. So that's input, that's reading something in. For output, it's basically the opposite. You open it, okay, using output file stream. You redirect your data into the output file stream, and then you close it. Okay? Take a look at this slide later on. It will be helpful for assignment 2. Okay? But that's how you read and write files in C++. It's really simple. It's just for input and output redirection. Okay? So it's none of this fprintf type stuff that you would have seen in C when you did that. It's all about this input and output redirection. Okay? So you shouldn't be using fprintf or fgets or anything like that anywhere. You should be using these file streams. Okay? There's a lot of stuff you can do with these file streams. Okay? This program I'm going to show you up on the screen. Okay? This one, which is called formatting.cpp, okay, shows you lots of things that you can do with formatting. Okay? So we can just print out the number 1331. We can print out the number 1331 in hex by sending a message to the output redirection to format this as hex. We can print a double, defined there. We can then set the formatting for the double and print that. We can also set for precision and print that. We can print something as as a decimal. We can set what we want to appear in front of some numbers. We can set the length of the number we want to print out. Okay. We can left align stuff, we can justify stuff, okay? And we can print a whole ton of things out. So again, there's lots and lots of stuff that we can do. So if we look up onto this right-hand screen here, if I compile and run this demo. Okay, so it's just compiling. That's what it looks like when it prints out. So for 1311, just prints out as 1331. In hex, that's 533. By default, when it gets printed out as a double, it gets printed out with 2 decimal places. We can set it to print out scientific style, so that 4th line down here for 1 with the plus E plus 03 there. Okay, that's in scientific notation. Then we can shorten it down, so still in scientific notation, but we've shortened it down to only be 3 decimal places on the end, which is there. Okay. Okay, then we've just set it back to print out normally again. And then, as you can see, these X's are full X, okay, the code on the left-hand side and what's done on the code on the right-hand side. Okay? So, let's put the X's in front or behind the number. Okay? Again, have a play with this stuff later on. For assignment 1, where you've got to print the stuff to 3 decimal places, I've given you the starter code for how to do that. Okay? Okay, and that's the output there, and it's the same as the output on that screen.